This is the GMAT 41. You're welcome to our elementary mathematics class. In this class, our focus is on combination. In our previous class, we studied permutation as a way of arrangement, where we learned that if you're given n objects, to arrange them in a particular order, maybe you pick r of them to carry out the arrangement. And we learned that in order to do that, we use the knowledge of permutation. Combination, which is the focus of our class today, has to do with selection. Just imagine that you have a group of people, and then you are to form a committee from this group of people. In this group of people, we have male, we have females. Out of these males and females in this group, you are expected to select some males, some females to form this committee. How can you go about your selection? That is what combination deals with. So how on the board, our combination is the number of ways of selecting R objects from n different objects. Mathematically, n combination R, which of course is the symbol of combination, or you can express it in this way, using this square bracket, then n and R under, or you express it as combination bracket n comma R, is defined as n factorial all over n minus R in bracket factorial times R factorial. So that equation 1 is the mathematical definition for combination. So when you're solving a problem in combination, you want to remember this equation. Now, we observe that n factorial divided by open bracket n minus R close bracket factorial is the definition of permutation. Do you remember that still? N permutation R is equal to n factorial all over n minus R in bracket factorial. So if we extract this n factorial open bracket n minus R close bracket factorial, that will be defining our permutation for us. So in all, you can see that there is this relationship between permutation and combination. That is what is expressed by equation 2 on the board here. N combination R is equal to n permutation R divided by R factorial. Is that okay? We have this example on the board here. Imagine you're given 8 combination 5 to evaluate. N there is 8, R there is 5. So it's going to be 8 factorial all over 8 minus 5 in bracket factorial times 5 factorial, following this equation 1, right? And that will be equal to 8 factorial divided by 3 factorial times 5 factorial. The 3 factorial is obtained from 8 minus 5. Now, in expanding the numerator, you would recall under permutation that we stated that we need to be guided by the denominator. Is that not so? The denominator will have 5 factorial. The numerator has 8 factorial. So when expanding the numerator 8 factorial, you're going to be guided by that 5 factorial. So we're going to stop at 5 factorial so that it will cancel the denominator 5 factorial. Is that okay? So that is why here I expanded 8 factorial up to 5, and then I stopped at 5 factorial, which of course will divide the 5 factorial in the denominator. Then 3 factorial, I decided to expand it so that you would see how it gives us 6. Is that okay? 3 factorial is 3 times 2 times 1. Remember our factorial definition. So these 3 times 2 times 1 will cancel this 6. Because 3 times 2 is 6, times 1 will also give you 6. So it goes off with this 6, you're left with 8 times 7, which will give us 56. So 8 combination 5 is equal to 56. Now let us look at complementary combination, alright? Complementary combination. So we've got this set of principles, you want to be guided by that. If we have n to be equal to k plus l, are you following, right? Then it means that n combination k will give us the same value as n combination l. Think of this. 8 can be obtained from, let's say, 3 and 5, because 3 plus 5 will give us what? 8. So it means that 8 combination 3 will give you the same value as 8 combination 5. Is that okay? Since 3 plus 5 is equal to 8, you can say that 8 combination 5 is the same value as 8 combination 3. Because we know that 3 plus 5 will give us these 8. The same goes with others. If you have 1 plus 7, you get 8. So 8 combination 1 is the same as 8 combination 7. What about 4 plus 4? So 8 combination 4 will still give you 8 combination 4. Think about 6 and 2. So 8 combination 6 would give us 8 combination 2. So if you add any two numbers, of course you get a higher number. So that higher number combination of any one of the two numbers you added will give you the same result. Can we quickly imagine 1? If you do something like 5 plus 6, you'll get 11. So 11 combination 5 is the same result as 11 combination 6. Now, following from this first principle, we could say that n combination r is equal to n combination n minus r. Where if you look at this 8 here, is actually 8, sorry, this 3 here rather, was actually obtained from 8 minus 5. 8 minus 5, you get these 3. So where our 8 is n in this case, are you following? So it's telling us that n combination r will give us the same value as n combination n minus r. As an example again, 8 combination 5 is equal to 8 combination 8 minus 5, which gives us 8 combination 3. In the next video, we're going to consider some other principles of combination, and then we'll be set to start solving questions on combination. In the previous video, we established that the mathematical definition of combination is n combination r equal to n factorial divided by open bracket n minus r close bracket factorial times r factorial. That's the general definition of basic combination without any condition imposed. Let's say you have maybe n objects and then you are to select r of them at a time. So the number of combination in such a case is given as n combination r, straightforward. But what if the selection is to be done under certain condition? Imagine that in a group of people you are to select certain numbers, alright, from that group, and then a condition is imposed that one person must be included in the selection, or a condition is imposed that a particular person, one particular person would not be included in that selection. How do you approach such combination problem? What number of combination would you obtain under this condition? Of course, it will no longer be our base n combination r definition. That's why we have these principles on the board. Just two of them we want to consider. The first one, we have the number of combinations of n objects, taking r of them at a time, subject to the condition that one particular object is always included. Such combination is given as n minus 1 combination r minus 1. Then you can still use this notation for it. Is that okay? That's the bracket notation. Take note. The condition is one particular object is always included. Now, what if one particular object must not be included? So you have to exclude one object in your selection. Alright, so the combination in that case is given by this, n minus 1, then combination r, or n minus 1, then under it you put r, that's using this notation. Of course, in this case, you have to remove 1, because the condition is that 1 must not be included. It means the total number of people there are objects. It's assumed that 1 is not part of it. One object is not part of it, since you mustn't select that object. Of course, that's why in the total we remove 1 from it. However, the number of object items you are taking at a time, you are selecting at a time, remains the same. Just think of a situation like this. Let us say that maybe in a group of people, let's say a group of 5, you are to select 3 persons. Are you following? And then 1 must not be included. If you think about 1 must not be included in your selection, it means that the total number already to select from is 4, because 1 mustn't be included. But that does not change the fact that you have to select 3, because we said you're taking 3. If you remove 1 from 5, you're still left with 4. Your selection is to be done such that 3 will be picked at a time. So that's just the reason why you notice that in this R, we are no longer subtracting 1. But in this total number of people or objects, we removed 1 from it. Remember the condition. The condition is that one object must be what? Included. must be included. It is now time for us to pick questions and solve. In the next video, we shall look at certain problems. We've got this question on board. We are going to solve to obtain the value of n. If n combination 3 equals 120, find n. How do we approach this question? We're given n combination 3 to be equal to 120. We do not know the value of n. We'll have to apply the definition of combination to this. So we need to recall that n combination r is equal to n factorial all over n minus r factorial r factorial. That implies we know the value of r. R is 3 in our problem here. We don't know n, so we're going to write n combination 3 is equal to, applying the definition, it's going to be n factorial all over n minus 3 factorial times 3 factorial, and from the question this is expected to be 120. Now we're going to do some expansion. We're going to expand the numerator n factorial. Remember the definition of our n factorial from permutation. Now in expanding n factorial in the numerator, you know that we have to be guided by the denominator. That was what we learned from our permutation class. So I'm going to expand n factorial up to n minus 3 factorial, and I will stop so that the numerator n minus 3 factorial will take care of that of the denominator. So this implies that n times n minus 1 times n minus 2 times n minus 3. Good. I'll now put factorial all over n minus 3 factorial times 3 factorial will be equal to 120. Now this n minus 3 factorial will cancel this n minus 3 factorial. Be left with the terms n bracket n minus 1 bracket n minus 2, and that will be equal to, this denominator is 6. 3 factorial, 3 times 2 times 1 is 6, so we need to cross multiply, is that not so? 6 times 120 is going to give us 720. Now let us expand this term and see what we're going to get. You can take your time to expand it, like expand this n minus 1 times n minus 2 first, and then use this n to multiply out. Is that okay? So let's go about that. So this is going to be n brackets, this bracket multiplying this. I'm going to use the knowledge we applied in polynomial multiplication when we treated polynomial in previous classes. So I'll check for the highest power here, the highest power of n here, that's going to be n times this n, which is n squared. Then I'll check for terms that will give me n raised to the power 1. This n times this minus 2 is going to give me minus 2n. Then this minus 1 times n will give me minus 3n. So give me minus n. So minus 2n minus n is going to be minus 3n. Then terms that will give us constant. Minus 1 times minus 2 will give us plus 2. 4 to 7, 20. And open up with this n now, we'll get n raised to the power 3 minus 3n squared plus 2n. This 720 can come over here to become minus 720. And that will be equal to 0. Now at this point you notice that this is a polynomial of the 3rd degree. That is polynomial of degree 3. So we're going to do certain factorization here because we are looking for the value of n. So once again we'll take our mind back to what we learned under polynomial factorization. I'm going to use the general method of solving this problem. Is that okay? The trial and error method. So quickly looking at this, I would search for factors of 720. I'll use those factors to substitute for n here and check the one that will give me 0 according to factor theorem. Is that okay? So let me say let n factorizing the 3rd degree polynomial. The 3rd degree polynomial. So let's see what we're going to get. Let n be equal to 10. Let me start from a higher factor of 720. Factors of 720 start from 1, 2, 3, I think 4 is also a factor. Then you continue, next is 6. 8 should be a factor as well, so are you following? In that order. Okay, So 10 is a factor. 10 can divide 720, you get 72. So I'm trying n equal to 10. Let me substitute n equal to 10 here and see if I'll get 0. So 10 raised to the power 3 minus 3 bracket 10 squared plus 2 bracket 10 minus 720. What is it going to give to me? This will give me 1000. We know that, right? This part will give me 300. 1000 minus 300 will give us 700. This is 20. 700 plus 20 will give us 720. 720 minus 720 will give us 0. Therefore, n equal to 10 is a solution. Is a solution to the polynomial. Are you following, right? So what are we going to do? Use n minus 10 to divide the polynomial. So here we're going to do polynomial division to get the quotient. Then we'll check whether the quotient can factorize so that we can get the other two possible values of n. Already we've gotten one value of n because when we substitute it here we got 0. Are you following, right? So we're going to do polynomial division now so as to get the other values of n. Okay? Let's go for a short break. Look at what we've done up to this point. When we're back from the short break, we'll carry out our long division of polynomial to see if the quotient can factorize. You're welcome from the short break. So, we've been able to obtain the first possible solution of n, which is n equal to 10. Because when we used this n equal to 10 as a factor of 720, we substituted it into this degree 3 polynomial, it gave us 0. And according to factor theorem of polynomial, when the factor of the constant substituted into the given polynomial produces 0, then we can say that that is actually a factor of the polynomial. And from there we can get the root or the zeros of the polynomial. That's what we've obtained here. Now we're going to carry out our polynomial division using this n minus 10. So, I'll draw out my long division sign. N minus 10 is the divisor. The polynomial n cubed minus 3n squared plus 2n minus 720. So let's do the division and see. N can divide this n cubed, will give n squared. N squared times minus 10 will give us minus 10n squared. Remember, n squared times this n would actually be a waste of time because you've already divided what produced this n squared. In fact, let me cancel it out. We've already divided it. If we use this n squared to multiply this n, we'll get n cubed. Write it under and subtract, you still get 0. Alright, let's proceed. So I'll subtract and then see what I'm going to get. Minus times minus is plus. Minus 3n squared plus 10n squared will give us 7n squared. Then I'll bring down this plus 2 because there is no like term of it in the denominator, maybe in this expression here. Then minus 720. Again, we'll continue with our division. 7n squared divided by this n will produce plus 7n. Then that plus 7n times this minus 10 will give us, remember I divided this 7n squared, so let it go off. 7n times minus 10 will give us minus 70n. Again, we're going to subtract. Minus times minus is plus. 2n plus 70n is going to give us 72n. I'll bring down this minus 70 because there is no like term of it on this line. Now the degree of this remainder at this point is equal to the degree of this divisor. So we carry out our last division. 72n divided by n is going to produce plus 72. Use the 72 to multiply this minus 10, but take note you divided this 72, so let it go off. 72 times minus 10 will give us minus 720. So let us subtract. Minus times minus will give us plus. Minus 720 plus 720 will give us 0. Is that okay? So we've arrived at our division. This is the quotient. n squared plus 7n plus 72. We'll check whether it can factorize. But unfortunately, if you look at this term, there are no two numbers which are factors of 72, such that if you multiply them, you get this plus 72. If you add, you get plus 7. There are no two factors of 72 that can do that. So you can say that n squared plus 7n plus 72 cannot factorize. And because it cannot factorize, it means it cannot produce any solution for n for us. In fact, if you solve these using almighty formula or quadratic formula, you're going to get imaginary number. You're going to get what? Imaginary number. It will produce complex roots. Try to use b squared minus 4ac, the discriminant you encounter under quadratic equation. b squared minus 4ac. b is 72. If you square it, you're going to get 49. Then 4a. a is 1. 4 times 1 is 4. Then 4 times 72. Work it out, you're going to get something like 288. Then you do b squared minus that 4ac. You notice that you get imaginary number. So cannot factorize. Therefore, let me conclude here. Therefore, the only solution, the only possible solution of n is n equal to 10. And this is our answer. Take note, suppose this can factorize to give us real numbers. We could have factorized it. Are you getting me right? Get those real numbers. Since this is a polynomial of degree 3, the possible values of n from here is supposed to be 3. But unfortunately, the quotient, quadratic equation we obtained here during our polynomial division could not factorize. And in fact, if you try to solve it out, you're going to get an imaginary number. The square root sign in the quadratic formula would give us square root of minus a number that minus that number, which of course is imaginary. And that's why we can no longer do anything here. Pick the only possible value, which is n equal to 10. So the solution for this problem, the value of n is equal to 10. Now we have this second question. N combination 14 is equal to n combination 10. What is the value of n? How do we approach this question? It's actually a simple one, right? So we're given that n combination 14 is equal to n combination 10. For these two combinatorial terms to be equal, simply means that the summation of r in both of them will give us n. So we're going to use complementary combination principle. So you can say, recall, if n combination k is equal to n combination l, it implies that n is equal to k plus l. Therefore, if n combination 14 is equal to n combination 10, it also implies that n will be equal to 14 plus 10. And then n is equal to 24. That's the value of n here, right? One can, however, choose to solve this thing using the formula of combination. N combination 14, n combination 10. Then do your expansion for both sides. Cancel out terms and solve for n. That's really going to be a stress. The fact that two combinatorial terms are equal simply means that if you add the r in both cases, r here and r here, you're going to get what? The n. In our next question, we are to determine the value of n, given that combination n, n minus 2 equals combination n, n minus 3. So we'll find the value of n in this case. Right, so let's see how we approach this question. Combination n, n minus 2, close bracket, is said to be equal to combination n, n minus 3. Now I want to take note of something here. This is n, combination, this term, n minus 2. So you can take this as our r in this case. Let's say this is r1. Let's call it k as usual. Is that okay? r1 or k. I'm going to use r1 as a notation for that. And then we have that to be equal to combination n, combination n, n minus 3. Take note again that you have n here, just like you have this n, combination n minus 3. So this term, I'm going to call it r2, or I'll call it l. Now you take note of something here. This is n, combination this term. This is n, combination this term. Both combinatorial terms are equal. So what do? you apply the principle of complementary combination, just like we did in question number 2. So you're going to recall n combination R1, if it is equal to n combination R2, then R1 plus R2 will give us the value of n. Are you following, right? That's the condition for complementary combination. So let me indicate. So with this principle, we're going to solve for n, means that n is equal to R1 plus R2 or k plus L. In this case, the R1 is n minus 2. So we're going to add it to R2. R2 is n minus 3. So what we're going to do is to solve this term and see what we're going to get for n. Open up this bracket, it's going to give us this term. Then n is equal to n plus n is going to be 2n. Then minus 2 minus 3 is going to be minus 5. Collect like terms. This is going to give us n minus 2n if this 2n crosses. So n minus 2n equal to minus 5. So minus n is equal to minus 5. Of course, we can divide through by minus 1 or multiply through by minus 1 this term here, right? To eliminate the negative sign from what we're looking for. So simply, this minuses will cancel because if we multiply through by minus, this will become positive n, this positive 5. So the value of n here is equal to 5. And that is the solution to this problem. In the next video, we're going to see an alternative way of solving this problem, alright? But this is the easier format to approaching a question like this. Now in this video, we want to look at an alternative method of solving this problem to obtain the same result as we obtained in the previous video. Remember that in the previous video we used the complementary combination principle to solve this problem, which is really simple, straightforward, and faster. Now I want us to use the real definition of combination to solve this problem and see if we'll still get the same result. Is that okay? Remember, we obtained n to be equal to 5 for this problem using the complementary combination principle. So let us see how it goes. Alternatively, using the combination definition, recall n combination R is equal to n factorial divided by n minus R factorial times R factorial. Now, combination n comma n minus 2 equal to combination n comma n minus 3 implies that n combination n minus 2 is equal to n combination n minus 3. Take note in this case that n minus 2 is our R here, and then n minus 3 is our R in this case. So we can apply the definition of combination to this equation and see what we're going to get. It implies that n combination R, where R is n minus 2, will give us n factorial all over n minus, n minus R. Our R is n minus 2 here, so it's going to be n minus 2. Once again, take note, R in this case is n minus 2, okay? So n minus our R, and close this in bracket, you have factorial, times R factorial, and R here is n minus 2. N minus 2 factorial. So this is going to be equivalent to n factorial all over, come to this term, n minus R. So n minus R here is n minus 3, is that not so? So we're going to put n minus 3 and close in brackets, then we've got to put our factorial, open bracket, R factorial, and R is n minus 3. So you have n minus 3 factorial. So that's the definition to this problem using combination of definitional formula. We can now solve this equation. Let us look at this term in the bracket here. If you open up this inner bracket, this minus times this n will give us minus n. Minus times minus 2 will give us plus 2. So this term would become n factorial all over. If this is minus n, you have n minus n, which is 0. Then plus 2 factorial, that is 2 will be left, minus times minus will give us plus 2. Factorial, bracket, n minus 2 factorial. Do same here, this is going to be n factorial all over. If you open up this inner bracket, minus times this n will give us minus n. N minus n will give us 0, goes off. Minus times this minus 3 will give us 3 factorial, that's plus 3. You have a factorial out there. Open bracket, n minus 3 factorial. I think it is time we need to expand the numerator now, okay? And in expanding the numerator, we need to be guided by the denominator. To know the extent to do our expansion. This n minus 2, so I'll expand n factorial up to n minus 2 factorial. So this implies that n times n minus 1 times n minus 2 factorial will be divided by 2 factorial n minus 2 factorial. That will be equal to n times n minus 1 times n minus 2 times n minus 3. Going to stop in here, factorial. Stop in here because of this n minus 3. So 3 factorial bracket n minus 3 factorial. Can we now see terms that can cancel out, okay? This will divide this. N minus 3 factorial will also divide n minus 3 factorial. Now, take note of something. You have n in the numerator here times this bracket. You have n here times this bracket times this bracket. Do you know mathematically you can divide through by n times n minus 1? It's just like you have 3x equal to 3xy. 3 times x equal to 3 times x times y. The 3x will divide the 3x on the right hand side of the equation. So you have 1 equal to y. So you're going to apply that here. This n will go off with this n. And then this n minus 1 will divide this n minus 1. The numerator here, what is left is 1. You know, if you divide all terms such that you can't see anything there again, what will be left there will be 1, okay? So this is going to give us 1 in the numerator all over 2 factorial is 2 equal to, this term here is n minus 2 divided by 3 factorial is 6. We can now cross multiply at this point. This 2 will multiply these terms here, n minus 2. 2 times this n will give me 2n. Okay, let me indicate, I'm cross multiplying here. Cross multiply. Doing that 2 times n will give us 2n. Minus 2 times 2 will give me 4. That will be equal to 6 times this one will give me 6. Collecting like terms, 2n will give me 10. Because minus 4 crossing over to 6 will become plus 4. That's 6 plus 4 is 10. Can we divide through by the coefficient of the unknown? That is 2 here, is that not so? So n will give us 10 over 2. Therefore, n is equal to 5 as before. As before. Right. So, this is our result. Answer. So you see that whether you use complementary combination definition to solve this problem, or you use the direct combination definition to solve it, you will arrive at the same result.